Wait,
Yes.
yeah, so Apache Airflow has the ability to schedule things.
Okay.
And it is in Python, so you shouldn't have trouble with it. Yeah, so Apache Airflow has the ability to schedule things.
Oh, I'm sorry, guys.
And it is in Python, so you shouldn't have trouble with it. Yeah, so Apache Airflow.
All right. Well, thank you for your answer. That's the idea that I had, but it's I just didn't know if that was like the right approach.
Hey, Evan.
Hey, sorry I'm late. What's up, y'all?
How's it
No worries.
going?
Ryan's trying to do something with Apache Airflow, so it's a coincidence that you just hopped in.
Oh, awesome. Cool. You're presenting tonight?
No.
Oh.
No, I just I had an idea, and actually it's because of you, because I remember you mentioning Apache Airflow. I don't know anything about it, but like I just vaguely remember you discussing like how you could use it to automate like data tasks. So I want to incorporate that into my work. Yeah.
Oh, that sounds awesome, man. Yeah, feel free to message me if you have any questions.
How difficult is it to learn? Like, I guess there's like some learning curve, but I guess assuming like the base knowledge is someone that graduated from the boot camp.
Yeah, I honestly think it's just like I think it's super easy. Like you don't use anything more complicated than a for loop. You know, it's very declarative. There's not really much functionizing, unless you decide to use it to orchestrate Python functions. So I think you could definitely pick it up.
Okay, awesome. Thank you.
Cool. So what's on the docket for today? Tests, right?
Yep.
Yeah, I'm going through testing. I've watched the videos on different testing paradigms. I've got like peaks and like valleys of how much I've tested code. I wanted to share a bunch of thoughts on it and kind of take it from there and show you guys what I'm doing in my current project. And actually, I made a switch from one testing paradigm to another, and I'll tell you why I kind of did that.
Cool. All right.
Yeah, so we'll start in another 5 or so minutes to make sure everyone's here. We just went through the time sheet, and essentially most number of people wanted it at either Monday or Wednesday, and most people wanted it around 7 p.m. So we'll probably just stick to the same time until we have more information.
All right, cool. Sounds good to me. I almost put down that I would want it earlier for some reason. I don't know why I was feeling that, but then I kind of walked that back, and I'm good with the time.
Yeah, I mean, if I could consistently do it earlier, I wouldn't mind, but I feel like work sometimes leaves late. Like, I literally had a meeting that ended 5 minutes before 7. I was like, okay, we need to hurry up this meeting because I have somewhere else to be.
Wow, no way. All right, cool.
Yeah. That's a late meeting.
Yeah, man.
Yeah, it is. Weird people in California, so.
Oh,
yeah,
that's right.
But yeah.
What's it end-to-end?
Yeah, Ryan, I'll send you. I've been seeing some really great, like, there's a small community on Reddit for data engineering, and there's a ton of people who just don't work in the field but keep putting together like projects to show that they have experience to work in the field. And so there's a lot of like good beginner like end-to-end pipeline stuff. Not that you would want to like copy it entirely or like even do that in your free time, but it could just answer any little questions you have. I'll try to.
I wouldn't put it past me. I will shamelessly steal. But no, I'm working with like student data. Well, I guess I'm not sure if I ever like introduced myself. So like I'm like a data analyst. The actual title is like institutional research analyst at Columbia. So I work in the engineering department. And
awesome.
yeah, just lots of like student data that we go through. So what I proposed was because there's so many of these like repeat data inquiries. It's like I think there are definitely ways that we can automate it, and that's why I got hired. So yeah.
Yeah, for sure. do that. I think that's awesome. So there's not much automated there right now.
They're so like outdated, so like stuck in like like outdated ways that I'm trying to use my position to kind of introduce like for example, there was this big presentation. So I'm not sure if you guys have heard about this, but like dealing with international students at like all these like big universities is like a really big deal. So we've been collecting like survey responses to like when they're planning on arriving, and so I just did a simple for loop to like segregate data by like departments, and like they were blown away by that because like I could like produce charts like 20 charts in like 30 seconds because you could just run like a simple for loop. So like something like that like is unheard of to them. So yeah, I definitely want to.
Which department do you work for again?
Wow.
Or the university?
I'm not sure if I want to give too much information. Like,
Yeah.
I mean, you could find me, but it's like I work in the dean's office of the School of Engineering.
At Columbia?
Yeah.
Oh, that's awesome.
Well, not as prestigious. I tell people that it's like I'm a data analyst that happens to work at like a top university. Like, there's nothing. I'm sure there are companies and other institutions that maybe like it's a big deal, but I just think I just happened to work at like a more prestigious like institution. Like, it's not.
Yeah, but that's like a great place to be. Like,
I know, yeah, that's
simply because of like, well, I guess like connections or whatever. But I think just the idea of being somewhere where they haven't automated anything and they're open to you actually deciding how you want to automate things.
Yeah.
Is just like such a great opportunity to explore some stuff, try some stuff out, and not worry about like too many deadlines or anything, and just kind of grow yourself.
Hey, Harlan.
For a starting position, like, it's excellent. Like, I couldn't have asked. Like, if I don't feel any pressure. I'm not having to compete. I have all this time to learn, and like they can't blame me when I mess up because they don't know any better. But yeah, they get like a sense of like how backwards they are. Like, I'm having to fight to get SQL access. So,
Oh right,
Yeah.
all right.
Yeah.
So you work at Mud Building?
Yes, it's funny. Like, I was the boot camp when I was attending. It was on like the 10th floor,
Right.
and I'm gonna be on the 5th floor. So
Oh, you're on the 5th floor.
yeah,
Alright,
That's
cool.
funny.
yeah. Thankfully, the offices are like remodeled because I was like, not to like be snobby or anything, but like they had this kind of like old like 70s, 80s feel to them, and
Oh yeah, completely.
yeah. So yeah.
We know some of the areas are shitty in that building.
Yeah.
That's very
you
cool.
know, I'm very thankful, but it is kind of like a weird thing. Actually, I forget the guy's name, but the liaison.
Cameron.
Yes, I was in a meeting with him. Like, it was just like really weird, like full circle. Like, yeah, like seeing him on the first day, and then now I'm like attending a meeting.
What's his name again?
Timur.
Oh, Timur. Oh, yeah. Oh, I have him on LinkedIn. That's right.
But yeah,
Alright.
the link, Evan.
Yeah, no problem. Check it out. I just I saw that project recently, and I was pretty impressed by it for like a first project or something. So a great thing to take a look at.
What is the project?
It's some airflow project I saw on Reddit as like I put it in text, as like a beginner project where this guy's trying to break into data engineering. So I was like, wow, this is actually awesome. He does everything from data modeling
very
to
topical.
orchestration. Yeah. So it's just something he can reference if he has general questions about any of those technologies.
This looks like a legit project.
Yeah, I know. I kind of want to do something like that. But, like, this is literally what I do at work all day, and it makes me question if I want to actually do it in my free time some more, just to show people that I can do it when I can talk about it a ton.
Wait,
So-
I thought you don't enjoy it. Aren't you looking for a new job right now?
No, I mean, I'm always looking. I definitely enjoy some things more than others, though.
Nice.
Always looking is a good answer. I'm sorry, man. I interrupt you.
Look on this repository. It's essentially a massive link to like a bunch of other DIY projects that are very beginner friendly. Or I don't know if they're beginner friendly, but there are a lot of like tutorials on how to do things, right? So they like skip or like a lot across all things. So like there'll be Docker, command line tools, or bots, or crypto, a text editor. Right? There's literally a thing that is a making a text editor in Python, and so tutorials are cool and definitely worth a shot. If you're looking for some things to do that are definitely out of your comfort zone.
Hey Matt,
This is
you're
very aggressive looking macro list.
Matt, you're cutting out for like 5 to 7 seconds at a time, and then we like miss a sentence, and then we hear a sentence, and we have to like try to piece it together. Okay, Evan, do you hear the same thing?
Yeah, I heard you dropping out a little bit.
Yeah, I also
Sorry,
hear that.
1 second. Okay. Yeah, so the voice connected bar was bad and looking better now. Can you guys give me 5 minutes and I'll try and I think I have a solution for this.
Cool, totally.
Hey, Harman, how are you?
Hey guys, good. Just like sort of working.
Good to see you.
Working on something else side by side. So yeah.
Where's Evan? Oh, there you go.
I also was having some like weird connection stuff, so I just wanted to double check.
Hey, you guys should have come with us to hiking.
Oh yeah, I'm sorry. I had already made some plans to go to the beach, but I really wish I came. It seemed pretty awesome. You guys went way too late though. You must have been dying.
Oh man, it was rough. I mean, I don't know about the other guys, but I was dying. Oh my god, my legs was like giving up on me.
Yeah, man, you gotta be out there like 7 a.m. or else you're gonna get.
Oh, we get there like.
Why do you think we would die more because we go late? I think the only problem with going late is it was hard to find parking and stuff.
No, it's the
The
weather.
sun is like beating down at that point. It's
The
like no
sun?
morning breeze.
The sun wasn't that hot that day. It was nice. It wasn't very hot.
Oh, okay, cool.
Yeah, it was more the walking. Like, wow, it was pretty rough.
That's cool. I'm glad you guys had fun though.
Where'd Matt go?
Matt's got that like New Jersey internet.
I know his internet is not very, very, very nice.
Where does everyone live? I'm just kind of curious. I'm trying to find an apartment, and I think I might end up in Yorkville.
Oh, I am very close to campus actually, right?
Oh, really?
Yeah, I used to live on 116 and Morningside Heights. Drive. I'm sorry, and then I moved to 152nd and Riverside.
Okay. Yeah, I have a lot of colleagues that live in that area, but I don't know. I kind of want some distance from my work.
You still got to commute? I mean, you're working from home, right? I assume.
Right now, but given that we're having some students on campus, that by that day when we start returning to work, like physically, might be sooner.
Oh, I see.
Yeah.
Oh wow, alright. I'm down in Hell's Kitchen. I really like it.
Yeah.
It's like kind of a hell of a commute, I guess, though. Unless you really like city biking, 60 blocks.
Lee used to do that.
Lee did do that actually, like every single time.
I know. I used to see him
So
like
totally doable.
Lee and his city bike.
Yeah, I would bike from what was it? The World Trade Center every day.
Oh, wow.
Because that was where I would commute for work. Yeah, I live in Midtown East, but I'm moving to New Jersey. I actually wanted to move to the suburbs due to quarantine, but my girlfriend wants to stay in Manhattan, and so we compromised on the worst of both worlds. Jersey.
New Jersey. Like Jersey City or
Yeah, Jersey
further
City.
in?
No,
Okay,
no,
cool.
we're on like the second path off. But I mean, still horrible. I
yeah.
just wanted to like just go to the suburbs, right? Just live the small town life. But yeah, just make that work.
Leo, it'd be so funny if you moved like way upstate and you had like the classic like 2 acres of land, like a little forest in the back.
I don't need 2 acres of land, right? I'm not going to, maintain it. I just want to go and like, have like a standard suburban house.
Yeah. I
Because
mean,
like
I
living
totally
from
feel that.
home, like I want my own space. I want like a backyard.
Dude, I know. Backyard makes such a huge difference. Whenever I visit my parents' place, I'm just like, wow, this is so nice.
But it only became nice when quarantine hit.
Okay.
That's when it started to matter.
Well, that's when the city became like no longer appealing.
Yeah, there's nothing appealing about the city anymore, I think. I agree.
I don't know, man. I've been doing Central Park a couple days a week, and that is really nice to me.
Imagine a Central Park but without people.
In Queens, I don't have anything that big like near
Queens is not the suburbs. Queens is like a borough of New York City. I'm talking like not Queens.
there's
Like
definitely-
suburbs
depends
have,
where
like,
in
big
Queens.
parks.
suburbs. I'm definitely from the suburbs in Queens. I don't know.
But like, okay, the suburbs. Every suburb I've visited has lots of big parks that are not necessarily as big as Central Park, but let's say like half or a third the size. And there's only like 5 to 10 people in the whole park in any given day. And so it's just like very big and very empty and very and also nice like Central Park.
I
I
got you.
think that's like a standard suburban park.
I'll concede the point. I think that's fair.
Yeah, I'm surprised. So there's no park. There's not like big parks like Central Park in Queens. Is it just like Chinatown all over the place?
I guess there's like Flushing Meadow Park.
Yep.
That's actually really big, but I guess I don't know, parking and stuff like there is just kind of more annoying than anything. So I don't go.
Alright, so I've connected directly through the Ethernet, so I think my internet should be fine, but if it's not, let me know. Sometimes the voice connected bar does seem to drop. So hopefully we don't have a problem, but let's go through it.
Yeah, I think you
So I
fixed
created,
it. You sound much better.
awesome.
Yep.
Awesome. All right, so I created a little high-level doc to talk about. We're going to go through that. Then we'll kind of go through what I'm currently doing in my personal code base, and then we might actually do like an exercise at the end of it if y'all are interested.
Yep.
All right. Anyway, so this is just like a bunch of my thoughts on testing. I think there's a lot of opinions out there, and a lot of them are somewhat conflicting opinions, but that doesn't necessarily. Oftentimes when people have conflicting opinions, what they do is sort of compromise. And I think in regards to testing, this is actually one of the worst places to compromise because what ends up happening is each kind of testing paradigm has trade-offs, and when you kind of compromise across the board, you'll get a lot of different testing paradigms, and all of a sudden you have all of the trade-offs, not just some of the trade-offs. And so I don't know if picking one and sticking to it is the right answer, but I think there's definitely a worry of like, oh, just do as much as you can, and then all of a sudden your code isn't as well tested and whatnot. So the first point I want to make is that if you think about what testing is, it's essentially any sort of validation that you do on software, right? And so that makes it fundamentally like anytime you drop a print statement to make sure your code is working properly, you're doing some form of testing, right? It's not automated testing. It's very manual. It's very intensive. You're looking through the code, the output to actually make sure it runs properly. But in some form, you're doing validation. And in some form, also QA analysts that literally will go through an app and click on buttons to make sure that the app is running are also doing testing in some form, right? It's just not automated testing. So the thing to kind of start thinking about when you're thinking about automated testing is like, imagine if you had a button that you could press to literally validate your code, to tell you that your code works perfectly fine, right? So instead of having to you make a little change to your code, I have to go back and I have to look at this output, I have to look at this output, I have to look at that output, you can literally just press this button and automatically check all of that, right? And so that is the glory, like that is the goal of testing, and that's the promised land of it all, is essentially to have 100% confidence when you're coding, when you're refactoring, when you're releasing code, that your code is going to work as intended. It's like an aspirational goal. Obviously, there's always going to be gaps in between your testing suite and like what you could possibly test and what the reality of the coding base is. Like, for example, if you have if the bug in your code base is that you're working within a VPN, and so you can see the code, the production server working fine, but someone outside of the VPN can't. All of a sudden, you're like, how do you even test such a thing? And perhaps there's ways to test it, but the higher level of operation you go, it starts to become harder and harder to test things, and it starts harder to gain confidence. And so at the end of the day, like, the goal isn't to automate everything away. The goal is to just automate enough of it so that you're ultimately saving time, right? A lot of people, myself included at some point or another, have thought that testing is a waste of time and ultimately drains resources more than it adds benefit. And I want to make the claim that if you're like, the whole purpose of it should be to give you back time in the long run, right? You're going to be able to catch bugs before they go to production, and as a result, you're not going to have to end up debugging production code in like some sort of high stress environment. You're going to be able to be like, oh, we shouldn't release this, or oh, I shouldn't merge in this PR. So that's the ultimate benefit of it. I don't think it's necessarily a given. I've heard of various companies that do testing in very different ways to very different levels of success. You could be like very testing oriented and still have problems with production code and still have problems with the developer productivity, and you can be a small company that has very little testing and has still like a very stable app. So it's like a lot of people treat this as like a holy grail for a silver bullet, and it can be in a lot of regards, but ultimately that's not necessarily the case. So what should you be thinking about when you're thinking about like the different trade-offs, or when you should be thinking about different paradigms and when to use what paradigm? So the big things are like the runtime of the tests, right? So some tests are going to take a very long time to run. Some tests are going to be very quick to run. You want shorter tests, right? You want, as soon as you click that button, you want that button to finish, to give you that answer as quickly as possible, right? So if I have to click that button and it's going to give me that answer in an hour, I'm going to be like, oh, well, what am I going to do for the next hour? I'm going to be waiting for that answer. Whereas if that answer is in a couple seconds, which would be great, then I can hit that button very frequently and get a lot of feedback. And this kind of answers that question of if you had this magic button, how often would you press it? And the real answer, the ideal answer, is that you would press it every time you make any sort of code change that you think might work. So that way you're actually validating that the small snippet of code that you wrote works. And a lot of people wait until much later and after they've written a lot of code. And I definitely think that's not the ideal state. What you really want to do is be able to use your testing suite to kind of guide you to maintain a happy path. And as soon as you start deviating away from it, your testing suite's going to be like, no, it's all wrong. You got to figure out what's wrong. Any questions so far?
So far, so good.
Awesome. So another thing to talk about is the amount of developer work that it actually takes to run a test. And this is like one of the other things to talk about with the trade-off, right? If I'm actually arguing that tests are going to make you more productive and allow you to develop things a lot faster, then this is going to be one of the points where maybe that's not always the case. There's actually going to be times where writing tests is going to be more painful. You're going to waste more time writing tests than you are going to be gaining from solving that test. And actually, Tom and I encountered a very similar problem when we were pair programming. We were trying to make a bot, and me being like very testing oriented, I decided I was like, okay, I want to be able to test this bot and validate that we ran it correctly. And because of the implementation of Discord's like bot API, that proved to be very difficult. So we sunk like 2.5 hours into like this very long trek of trying to test this bot. And ultimately, like the amount of work we spent developing the bot at this point was like maybe half an hour, right? So there's no way I can argue that the 2.5 hours I spent and failed to develop this testing suite saved me time in the long run. So I'm going to talk about the different like paradigms of testing and where I think they belong, and actually some testing paradigms that I try to avoid for this very reason is that, like, when testing is super easy, a lot of people end up doing it, and a lot of your like coworkers will end up doing it. And when it's super difficult, it becomes the bane of programming. So you'll solve a problem very quickly, you'll write it very quickly, and then all of a sudden writing the test is like 2 or 3 times as much work. You know, I don't want to do that. And so it's definitely like the most important consideration to think of. The other thing to think about is the fragility of the coding base, or the coupling of your coding base to your production code. What does this mean? It means that if you're very granular and very hyper-focused with your testing suite, and you're testing every single thing that happens and every single line of code in like a very extreme format, it's going to become very difficult to change your production code without actually breaking your testing suite. So some people consider this as by design, that whenever you want to change your production code, you should by necessity change your testing code. And I think there's a lot of validity to that, in the sense that you definitely want to be knowing when your code is changing in a significant way, and you want to have to update it. You want to have to update your testing suite. On the other hand, if you're refactoring code and basically the functionality stays the same, you might want to be thinking about that there shouldn't actually be a lot of testing updates, right? And so what you want to have is that, okay, I had something that succeeded in writing my, right, like I created an API, I created a web app or something, right? And the web app sends weather information, right? And I can test all of the details of my weather app. But then when I change some of the low-level implementations, I'm like, oh, instead of checking on weather.com and forwarding this information, I want to go to some other website. Well, maybe all of a sudden my testing suite breaks. My application hasn't broken. My application still works. But now my testing suite is broken, and I have to update this testing suite in order to get it working. And so the question is that by design, or is that like a problem in it? And at some point, I definitely thought it was by design, but nowadays I'm starting to think that that should be the case. It should be the case that I should be able to really change the implementation details of my code without it actually affecting whether or not my testing suite passes. Okay, any questions on the trade-offs?
So
Appreciate the feedback, Evan. I need someone talking to me.
Else you go
I'm
crazy
sorry.
talking to yourself.
Talking to the void.
It's a void.
Yeah. All right. Test.
I think it makes sense too.
Thanks,
Awesome.
Lee.
So test-driven development. I don't know if anyone's actually implemented this. This is the exercise that I was considering adding at the end is to actually do test-driven development and have you guys see or experience what it looks like.
I've implemented this.
Test-driven development?
Yep.
Do you like it or hate it?
Gets the work done.
Yeah, so
It's pretty good.
some people
Great.
absolutely love it.
I have a clear idea of what needs to be built in advance.
So I'm like, I'll start getting background information. I'll comment on that. So test-driven development came out in the early 2000s by a guy named Kent Beck, who essentially, I've been listening to a lot of his talks recently, but essentially the idea that the problem that he had is that he was being a consultant and you go to a lot of these companies where they try to ship projects and they try to be like, okay, we came up with like a 9 months till deadline, and all of a sudden we're trying to get it to ship and we can't ship this code, right? And so he came in on this project trying to, with the explicit ask of making the code run faster, and they were like, oh, well, the code doesn't work, but we still want you to make it faster. And he's like, oh, great. If it doesn't have to work, I can actually make it run very fast. And I think it's like a very funny thing because it actually points that, you know, if you don't care about functioning code, none of the other things really matter. And so testing is driving towards that, like making sure that your highest priority is that code is functional. So he comes up with this idea, and essentially the idea is that you're going to write, you're going to have like essentially two streams of thought. One of them is the testing stream of thought, which is going to come first, and then the other is the implementation stream of thought. So you're going to write a test, the smallest test that can possibly fail when you try and run your code, right? So sometimes this is going to be like your compiler is not running because the model doesn't even exist, right? So that's like the easiest fail to run. Then you're going to go to the implementation side and you're going to implement the smallest amount of code to get your test to run, right? So in the case of if you're trying to create like a class, you're just going to create that class. And all of a sudden your test is passing, you're going to go back to the testing side, right? Then depending on what you're going to do, and later I think we're going to implement the stack, right? So a stack has a size operation, right? So I'm going to test that there's a size operation that returns 0 for an empty stack, right? Okay, that test fails. Now I'm going to implement the code to get that test to pass, right? So what you might think is that, okay, now I'm implementing the code to make a stack work. You should be implementing the code to make that singular test pass and no more, right? So at this point, all you're going to do is make a function or make a function on this class that is essentially a size function that returns 0. And your code doesn't meet your business objective, but it passes the test, right? And so you're going to keep adding tests until your business objectives are met by your testing suite, and then you're going to keep adding code so that your production code passes your testing suite. And it seems a little pedantic to kind of make it very explicit. With each step, you're kind of hopping back and forth. But there's like a bunch of benefits from this. And one is that like when you're done, you have a very good testing suite. That's actually the biggest one. Your testing suite at the end of it becomes incredible. And I don't know if anyone's tried writing testing suites after the fact, after you've already solved the problem, but I've always hated writing testing suites after the fact. It becomes very painful to be like, okay, I already know how this performs. I know that it performs. And basically I'm writing a bunch of mock code to make sure the thing that I know is already the case.
Yeah, that's a good point. It's always, I have not tried test-driven development. I feel like I would like to try it in the future. but I definitely always end up writing the thing, making sure the thing works, and then thinking, how do I test this in the end? And I think that always ends up being hackier than it should be, basically.
Yeah.
Do your coworkers have a strict code review policy, Evan? Because usually, from like a lot of teams that I've been on anyway, or like people that I've talked to, like no one wants to read your code. They just want to read like your tests and like briefly skim through your code for style.
Yeah, it's something we're actively working on. It's definitely not where it should be, but we're getting better.
That's very interesting because I've actually had the opposite experience where people don't really look at the test and they look at the code. But if people are looking at the testing suite and validating it, that I think is incredible.
Yeah, I think it's a good sign. Yeah, what is it in what's that famous Python book? Whatever they say, like
Learn
tests are
Python the hard way?
important. Maybe learn Python the hard way. I don't think so though. It's the one by the guy who made requests, Ken Reitz. It might be just like Elegant Python or something like that. He says that it should be really easy to learn about your code from reading the tests. Like that should be the way to jump into contributing to your code is to be able to read the tests and understand the code base. So just a way to relate these.
The hardest part about me onboarding in my current company is like I'm testing, like everyone's testing like all the new features, but no one tested like the initial deployment, like all the core systems. And so that makes it so hard to understand like what the fuck does this thing think that it's doing. Whenever there's a bug, I'm like, I have no idea because there are no tests and I can't like reading a complicated system actual code is hard.
Awesome.
That's a fantastic point. I think using tests as a way to describe your code better than comments ever could, right? So a lot of people have readmes in your code base. Like if you look at the actual testing suite for whatever class or service or whatever you're implementing, you'll get a very good understanding of what the API of it should look like what the external side of things should look like. And I think one of the other things I want to bring up with testing driven development is that when you write the test first, when you write the code first and the test after, it can oftentimes be very hard to come up with the test for the code. And the reason for that is that not everything can be tested very easily. So when you write the test first, you end up writing code that automatically is easy to test because the test is already there. And so a lot of different paradigms come up with how do you make code easy to test. And I definitely think it should be a priority to write code that's easy to test. And like, this is where I think one of the big ones that's coming up is dependency injection. And this is essentially instead of importing something as like in the top of the file where you say import something from something else, what you do is you pass that something into the constructor or into the init function of a class, and that's how that object gets passed in. And that way, if you need to test that to override that object, it's very easy to do that. And so, like, people don't think of using these paradigms until like testing becomes a priority or first-class citizen or whatever you want to call it. So one of the problems with TDD, and there's like I sent Lee this, or I think I sent it over in the text channel. There's a talk that was called Test-Driven Development, What Went Wrong? And he points out one of the things that I've noticed is that a lot of people will write a lot of extensive tests for basically everything in their coding base, and all of a sudden it becomes hard to refactor code because it comes back to that point I mentioned about developer productivity or like fragility and coupling a code base, because all of a sudden everything is tested, and now no matter what you do, you're going to break a test. And so you refactor something, and now you have to refactor the testing suite as well. Whereas ideally what you do in a different paradigm is you would just refactor the code, and the testing suite would validate your refactor. The testing suite would essentially say the code works as it worked before, it just the underlying implementation details are different. And this kind of came up with the term of behavior-driven development, where the idea is that you're not testing, it's not it's not built around testing. Testing is not the whole point. The whole point is that you want a certain behavior, and tests enable you to guarantee that behavior. And so, yeah, so they call it behavior-driven development. Here, I think there's somewhat of a divorce between what I'm going to talk about in a little bit, where essentially people talk about having more low-level unit tests and less service tests or UI tests or integration tests or acceptance tests, whatever you want to call it. But I think if you're focused around behavior-driven development, you're actually going to have more high-level tests. You're actually going to test the output more than individual functions, right? You're still going to test functions when you're like, my function is to trim a string. Okay, well, I know what this behavior is, and I can test this function. But if your function is like very tied to your actual implementation details, well, maybe you don't have to test it. Maybe you have to test, you're testing a higher level version of that. And so I think this is a very good place where the community hasn't really come up with a very good consensus around what a unit is, what you should be doing, like what the priorities of testing in behavior-driven development is versus test-driven development is. Because oftentimes people will, like the way I've often heard it explained is that behavior-driven development is just a renaming and rebranding of test-driven development so that the priorities are set. But from my experience, if you're actually focusing around behaviors, you're not focusing on low-level implementation details, and you start to need higher level tests. So I'm going to talk a little bit. I'll come back to this because I have to talk about like what high level tests are. Right. So I went through. Here I have like what I consider the 4 different levels. In this pyramid, they have 3 different levels. They basically map in some way or another into the same thing. But here's how I consider it. Right. So a unit test is in like the classic TDD example, is testing a small set of functionality basically on primitive data types, right? So when I'm talking about like testing the string.trim function, right, that's something where I can mock out a string, I can run this function on it, I can verify the output, right? And so I don't have to worry about other classes in my code base. I don't have to worry about like the architecture paradigms of my code base. I don't have to worry about like basically there's like a very small amount of code, and I can pass everything in that I need to that code base. Okay. The next level is kind of integration testing, and this is where you're actually testing some subset, most often like 1 or 2 or 3 things of your actual software architecture, right? So if you use like a service controller repository paradigm, what you're going to be doing, actually, let me go to Google Sheets. I had a thought about this that I wanted to share. So if you consider like an application, right? You might have different paths in that application, right? So you might have like a user path. You might have like a what type of app do we want to talk about? Let's talk about like finance. Let's talk about a bank, right? So we have users, we have routing, right? And we have stock trades, right? So these are different, basically, things under our application, right? And each of these have different details, right? So we'll have like a user API that literally describes how someone else should interact with the user object, right? And then somewhere underneath that, we'll have like a user service that basically is how do you actually, like moving past the API, we've talked about how someone introduces objects or introduces messages into your system. Now, what do we actually do to change things in the system? We'll have like a service level. And then we'll also have like a user repository below. So I call this API, but sometimes more often than not, this is called a controller. But basically, it's how you describe an API. Right? And so when you're talking about like unit tests, they are smaller than this application I'm designing here. I'm not going to call routing anymore. Let's call stuff. Let's call trading. Let's just use these two things. Right? And then accounts. Right? Let's say multiple people can have an account, so where it's different things. All right, so we have like an accounts service, accounts repository, right? And so unit testing, the thing that I'm calling a unit isn't actually even described in this diagram because it's very small. What a controller is going to test is basically going to test across one of these horizontal axes, right? You're going to test accounts, and maybe you're going to test account service, and then you're going to mock out account repository, and you're going to mock out account controllers. What do I mean by mocking out? So oftentimes when you have to like save data to a database, you don't want to do that in your testing suite. Why is that? Because reads and writes from databases, when you do them in a testing suite, can actually add a lot of time to your actual testing suite. This goes back to the point of making these things run as quickly as possible. So what people will do is they'll mock out, okay, I'll have a mock repository, I'll have a mock database. In this case, I'm calling a repository a database. And at this point, I don't have to worry about writing to a database, but I can test the functionality of being able to do that, or I can test that my account service is able to do that without having to worry about actually writing to a database. And then kind of the next level of this is acceptance testing, and this is essentially application testing. And so this is basically spinning up the entire application and then pretending you're like an external client and then calling things there, right? So you still might mock out databases, but you're not going to mock out your other assets. You're not going to, like, if accounts had to reference a user, at this point, you would actually have to pass in all of that information. Whereas in the integration testing level, you can actually mock those out so that those functions just can take blank values. And then kind of a step above that is end-to-end testing. And this is when you spin up multiple applications in probably like a staging or a testing environment, and then you run some sort of testing suite against that. I've done it in the sense where we ran UI testing suites, but that's not necessarily the case. You can still do end-to-end testing suites on multiple applications that are all just back-end applications. So kind of going back to where this is, they're calling UI tests, and I'm calling, this is where I'm describing like application tests or end-to-end tests. They're calling service tests, what I call integration tests or acceptance tests, and then unit tests is the same. And the idea of the testing pyramid that a lot of people advocate is making sure that you write tests with different granularity, having unit tests, service tests, and UI tests, and then making sure that you have more unit tests. This is actually something that I don't necessarily agree with. I'll go into a little bit more detail in a bit, but I want to stop for questions because I have just gone through a lot of information.
I think it all makes sense. I think it's hard to like really retain all this information without like real concrete examples of like this is some basic code and like here are the different types of tests to test different parts of it. But especially because I've been like doing a lot of testing recently, everything you said makes 100% sense.
Yeah, I mean, I'll open up my project and we'll go through the details. I didn't want to go through it side by side because I actually can't present two things. Or sometimes people see it, sometimes people don't when I present two things. And then so my project will be like still somewhat high level because you definitely still have to understand some things about it. But then when we actually talk about like Well, I mean, in order to actually talk about integration and acceptance tests, you need like somewhat of a big project. Um, but yeah. Okay. So this is like when most people think of testing, or when most people talk about it, is within these kind of four subsets is what they kind of branch it out in. There is other ways of testing that I think are very interesting and um, have different, like, are just like, are somewhat bizarre and like very interesting. So production testing. This is what I'm calling like basically Facebook's approach to testing, and I've been reading a lot more into detail. And Lee, if you have any points on this, definitely chime in. But essentially, from what I've gathered, and so like all this comes with this is what I read, but the system, the idea behind it seems sound. This is what I've read that Facebook does, and it's essentially that you use users to actually do the tests, right? Which, based on this other paradigm of making sure you never ship bad code, is an absurd idea. But what they'll do is they'll have uh, suites that essentially look at the functionality of users and see how they behave to a merged to a different state of code. And so, actually, this is sometimes called A/B testing. But I think production testing, in my mind, makes a little bit more sense.
Facebook is not really about how users react to different code. When they talk about production testing, they're not thinking of like, are users clicking on something more and we want users to be more active. It's more like if your code has like, it just crashes with some like inputs, if you just raise an error, and you shouldn't be raising an error, and so someone's like iPhone like either crashes or like hangs or some other really bad outcome, or like the screen like has some funky graphics on it. If that happened with your Facebook app, that would be like really bad, right? And so we don't have any tests, like any automated tests to make sure like your code doesn't, raise an error and like crash or the server not respond or any of these things. So we just ship code constantly, either to our servers or to like your phones. And we'll first ship to small numbers of users, because if people's phones start like either hanging or crashing or other problems, then that's an issue, and then we don't release that to like everyone. So like when I was a Facebook employee, I was the like first line of testers, and so my Facebook app crashed so frequently, and it actually one day I like couldn't use my phone at all for like 6 hours, just because I tried to open Facebook Messenger on my personal phone and it just hung and I couldn't turn it off. I couldn't restart it. I couldn't do anything. And so I had to delete all the Facebook apps to my phone because I didn't like being their first line of testers. But that's the idea of production testing, is we just see if the app crashes a lot with the new release.
So I'm sure they have other metrics around it, though, right?
So Facebook employees can also report bugs. So we have a special version of the app where if we see something that we think is like a clear bug, we can click a button and say like there's a bug here. And so if if everyone's apps are crashing, or if there are a lot of like bugs reported, then we won't release to the masses. Those are the metrics. That's the idea of the production testing. A/B testing is a completely separate thing, and we have A/B tests, but that's not about like shipping new code. Like A/B tests, like you're not shipping new code, and that code is the A/B test. You ship new code, and then you schedule an A/B test where your code is like enabled or disabled by some flag, but your code is like when you commit your code. that's like constantly production tested, and then you have to like schedule that. That's like a whole business thing about like scheduling A/B tests and like monitoring user feedback, like user engagement.
Oh, I thought the whole idea was that basically everything is A/B tested, and that over time you're like
they don't A/B test anything about production. No, like people just like interns commit code. There's no A/B testing. There's no anything. Interns are committing code to production constantly, and there's no like review that says like either this code should be removed or this code shouldn't be made it into production. But if our main branch starts crashing, like if users' apps start crashing, then there's a production engineering team that's job it is to like assign blame and to try to revert the commit that like crashed it, that caused the bugs to start coming.
That's interesting. I feel like, so in my mind, is that these two ideas very much align in the sense that what you're doing is that you're essentially using some sort of end user as the validation metric, and that what you're doing is tracking a lot of stats. And if those stats start going some negative way, like even like the idea that users are using the app less, right? So if you merge in some code that makes people use the app less, it doesn't matter if it's the application crashing or if it's just simply that the UI is no longer as pleasant, right? That code, they definitely don't want that code anymore. So that was my.
We don't have anything about usage in our like production engineering feedback system. It's really just reported bugs or app crashes. But because that's what's easiest for the production engineering team to debug, right? It's only those two signals.
Okay.
But yeah, you could imagine, like, especially if you were thinking of, if you were more organized about your pushes to production and you thought of this, like every commit to production as an A/B test, then that would make sense.
Okay.
So like literally commits to production are just like interns like adding some random code that doesn't belong there, just like constantly. Like just 24/7, every couple seconds there's a new commit to prod. In different areas of the code base, but all in the same code base. There's no branches. You're just committing to the master branch constantly.
But there's no branches?
I don't know how that doesn't even make
we have
sense to me.
Something like branches.
There's be so many merge conflicts. This sounds
because
unproductive.
like people, like how likely is it that some other engineer is editing the same file as me?
I guess there's
like
just
I can make my own. I forget
Yeah.
what we called it. We didn't call it a branch, but I can make my own thing. But then I'm going to commit that to production, like supposedly very quickly. We're not supposed to stay on a branch for more than like 1 or 2 commits before merging into master. Yeah.
Okay, well, I mean, that paradigm doesn't sound aligned quite as well as what I was thinking. This guy, Kent Beck, actually worked at Facebook for like 7 years and talked about like how it was very data oriented, and so I got this impression that like, based on what he was saying, that they were doing this kind of A/B test everything, and that's how they were able to like basically not write tests, but have like production engineers have these basically giant DevOps jobs to revert PRs and shit like that. But it doesn't sound like the case.
They're A/B testing everything about the user interface, right? But those are like scheduled, organized A/B tests. Those are not about if your code works or not.
Oh yeah, and it sounds like you have to opt into it, right? So,
Yeah. You have to like schedule it through like the business group that handles A/B testing.
Okay. Okay, so production testing no longer seems like a good idea to me. But A/B testing on steroids would potentially be an interesting idea, but it doesn't sound like anyone that I know of is doing it. I thought Facebook was doing it, but that's not the case. And then like there's a subset of it's basically regression testing. It's a subset of acceptance testing or end-to-end testing where you're not testing functionality. You're not writing behaviors and making sure the behaviors pass. You're essentially saying like, what did this return before, and does it return the same thing? Right. So this is very good for like data sets, and what you'll do is you'll be like, okay, I'm basically expecting that the data doesn't change, right, because of this refactor. Now let me query my API from last time, or query my API from before this commit, and query my API after this commit, and validate against each other. The validation aspect of it can be very tricky because your data model might change a little bit, and that might be a problem. You might have to worry about like ordering of things and whatnot. And this is the same thing kind of for snapshot testing, although I consider snapshot testing to be a somewhat lower level than regression testing. Consider regression testing to be basically like you do it on end-to-end systems, and snapshot testing to be like you're doing it in lieu of either integration testing or as acceptance testing. But these two paradigms are super related. And I like doing it on lower level things, and then that's why I call it snapshot testing. Oh, you know what? I'm going to actually make the distinction on these. So with regression testing, you use production data, and with snapshot testing, you manually write the data, and so you have a lot more control over the data. And so with regression testing, like it's a lot easier to have false positives. Although honestly, in both of these, you're a lot more likely to have false positives. But in snapshot testing, you don't have as much data because all the data is highly curated to what you want it to be. Right? You're basically you writing the test is you writing the data that goes into the test.
Yeah, good idea. Last week, I did the presentation on like the Jinja template SQL. I think I have tested it this way, and it probably is a good way to test it, I guess. Where like you have some data that you're in control of, you feed it into a template, and you get a SQL statement out. So then, how do you make sure that that function is always giving you back the same SQL statement? You probably take a snapshot of that, save it in a file in the test suite, and check against it all the time. That might be inefficient, not sure, but it's just another way to do it.
Yeah, I mean, so I think it's great. What I thought you were going to say is you actually run the query and then test the output. But yeah, you can actually test the SQL statement. And so the big idea is as the SQL statement is changing, you want it to change in your source code. And you want to change it in your source code, not in the sense that it changes. You don't just copy and paste it and you're like, this is what it's supposed to be. You actually run tests against what you expect it to be, so you have like, you know that it's failing. And the other thing to think about is that like, let's say you weren't doing testing. How are you actually validating your SQL, or how are you, or like the SQL text, or how are you validating that your SQL runs correctly? Well, you're actually looking at the data that you get back from a query, right? And this kind of goes back to like, at the end of the day, you're doing testing in some form or another. If you're manually looking through the SQL query, or you're manually looking through the data, or you're manually looking through like the HTML, that process can be automated in some way or another, right? So if you wanted to be like, okay, I've looked through the SQL query every single time, I basically know it should look like this. Let me take a snapshot of what it currently is, and then when it changes, I know when it changes. And so what I like think about testing, I think about the process of automating your own validation of the thing, right? So instead of like loading the UI and clicking through the UI, you're automating those clicks, right? Instead of querying a database, you're automating the querying of the database. And snapshot testing is probably the most aligned with oftentimes what developers do instead of testing. And I think it's very easy to implement a lot of the time, and so I think there's a huge amount of value that can be gained. It's not the end-all be-all. Let me go to my GitHub because I saw there's like this very good critique. Actually, no, this is Ember snapshot testing. this is the critique of this. And actually, yeah, this tweet is probably the best version of this. And essentially goes through a couple of like the problems of snapshot testing. And one of them is that when you actually write tests that are like very catered to your product, you have a lot more understandability of what the intention of the test was. Right? You have code that literally says what the code, how the code should be hit. Like you not only have code that would fail, you have code that, by the very nature of reading it, you get an understanding of what the code was intended to do. You don't get that from snapshot. You actually have to have that understanding in your head. And so that was point number two. Point number one is that they're hard to debug when you don't actually understand them, and you actually have to get a grasp of what's going on. Point number three is about being like people being undisciplined about them, and basically what they'll do is they'll update the snapshots every single time and not worry about like why the snapshot was updated. So I think there's still some benefit even if people are doing this, in the sense that now your source code can tell you what actually changed your code to get your test to fail. What do I mean by this? Well, if you had, like, if you found out later down the line that your testing, like something about your functionality failed, you can now just go to your source code and be like, okay, when did this output of the snapshot test fail? And then you kind of go back and you're like, okay, here's what it changed. Here's the PR that actually resulted in that change, right? And at this point, you can actually be like, okay, let's revert this PR, or let's diagnose what's wrong with it, and whatnot.
Oh, Matt, can I tell you about Facebook and this? I thought this was funny. This is something that every boot camper joining Facebook is very shocked by. It's that, so if I write a system, I don't have permission to like not allow other engineers to change it. So other engineers just, like they shouldn't change something that like they don't know if they own. But like theoretically, like an intern could change my code, and then when if I have a test set up where I say the output of this input should be this output, just like you guys were talking about. What do you call that? Like output testing. Like they can just change it. What?
Snapshot testing?
Yeah, snapshot testing. They can just change the snapshot also. So normally, like, if someone changes the snapshot of my system, I'd be like, why the hell are they changing my snapshot, right? And so the horror there is they can just change the snapshot expected output, and then suddenly the test passed, and they, commit the new system without any, test blocking them. So it's just, of course that's wrong, but that's the way they do things. And so, yeah, of course, like with snapshot testing, no one should change the output of the snapshot unless there's like a real reason to change the functionality. I thought it's an interesting example of like the absolute wrong way to do things. Like you would never want to allow like an intern to change the expected snapshot of the test because that's the output that their code gets.
So, I mean, it depends on what you're like. I mean, I guess it depends a lot on like your culture and what you're relying on to maintain production code, right? If you have this like powerful A/B testing, and then all you're relying on low-level testing for is to know when your API changes, then at that point it really doesn't. It like you can be allowed to change the API because some other testing suite is going to catch it. And so this kind of goes back to the thing that I brought up at the beginning, is that like there's a lot of conflicting opinions on these, and like taking half opinions and being like, oh, let's be like, okay, let's compromise, might be the worst thing you could possibly do, right? Because if your paradigm is that, okay, snapshot testing is somewhat good and production testing is somewhat good, let's do a little bit of both, or A/B testing, everything is somewhat good, and snapshot testing is somewhat good, let's do a little bit of both, all of a sudden you have none of the guarantees of either. Whereas if you're like, okay, A/B testing is what we're fundamentally relying on, then I wouldn't actually care if people update snapshots. Because at the end of the day, like, that's not the thing I'm relying on, and all I'm doing when I'm doing that is getting somewhat of a grasp on the coding changes.
Yeah,
Okay.
It was a really good read. Also.
Did you finish reading it? Yeah, this is I'll send this out. This is the big criticism that I against what I'm doing. I'm relying on snapshot testing a lot from personal applications, and there's probably reasons why it can still make sense. And some of that is like, if I'm the only one doing it, and care a lot about my application's performance, then some of these concerns go away. But if you're like in a bigger organization and like I've totally done it, and I've done it. The thing is, like, some of these problems don't just disappear because you're not using snapshots. Like the whole idea that someone just updates your testing file just to get it to pass and to merge the PR. I've seen that happen, right? Like I've seen people just edit like testing things just to get it to pass so that they can merge the PR. And you're like, hold on, like you literally changed the functionality and it no longer does what it's supposed to do.
That's pretty funny.
Yeah. Oh, another thing I haven't mentioned is about integration testing and how like heavy mocking of testing suites. Like one, there's a whole developer productivity thing, but another thing I've seen in the past is integration suites that literally just test the mock functionality. Right. So what'll happen is someone will write a mock for a test, and slowly that like test will change over time, and then at a certain point you look back on it and you're like, I'm literally just testing that the mock data I passed in is the mock data I passed in. That's it. And I get no coverage out of this, and I have this code that runs all the time, but doesn't actually provide me any benefit. And so this kind of goes back to like testing isn't the silver bullet because like you might not necessarily be doing it right. And I just find that funny. The idea that there are tests that are just testing mock inputs, and by mock, yeah, it's yeah. Okay, let's kind of go through my current repository. Okay. Close Windows. Okay. At some point in the future, I'm probably going to do it soon. I'm going to do a thing about domain-driven design and how I organize my code. But essentially, what does this code base do? This code base basically creates a course that's made up of lessons. And so you have this course folder at the top that I'm calling a tech course, and within that you have tech lessons. You have a bunch of other things that are like filtered courses, lessons, repository, a repo because I'm having this connection to Git, a subtopic which is a subset of lessons. And I'll go into like why I organize it in a specific way, but this is domain-driven design, and is what I'm implementing. It's an idea by Robert Martin, and I think it's like one of the most important ideas in organizing your code. So I definitely recommend
Robert
it.
Martin.
But I'll do a lesson at some point. Anyway, I initially started off by writing a lot of integration tests. And actually, let's integration tests on. Have I removed the integration tests? I feel like I might have removed the integration tests on tech lessons. Maybe I unit test it. Go ahead from mocks.
Are you streaming development on Sunday?
If I go hiking both days, I'm not going to stream.
Gotcha.
That's my big idea nowadays. Okay. Here's like an example of. So let's talk about a lesson real quick. What essentially a lesson has is it belongs to a course, so it's going to have a course object passed in. I actually make it an optional course object, and so the reason I like this kind of goes back to like things need to exist in a context, and that context is basically the entry point. And so if you ever want to reference a lesson, you have to reference it from a course, basically because a lot of these other functions rely on that fact. Commit file is basically me loading from a database, and in this case, this database is actually local files, right? So it's going to read from this like content folder, and this is like instead of writing to a database or having all of my data in a database, I decided to keep it locally because I have absolute control over it. At some point in the future, I might change that, but I don't see a need to do it now. Getting the file names, right? So the project is basically that each lesson is a series of files that form a commit, and so this thing is going to read the file names, right? And so like a lot of this functionality is basically just that. Let's go through something that I did in the mocking. Oh, these mocks suck. Yeah, I stopped doing mocking because I hated it. So what did I do? A lot of people, what they do when they mock is they'll pass objects in differently, right? So what, if you go to the actual model here, what you would do is you pass different IDs or different course models passed in, right? And so you mock the test by passing these objects in differently. One of the things that is, right, so if I wanted to be able to mock a database, what I do is I pass in a database, right? Probably have like a public read-only database, and I'd be able to pass this in, right? And I have some like database object that it is, right? And then when I actually go to write the test, what I would do is I would pass in that fake object, right? I pass in some, all right, a blank tech course and then an object, right? And this is like find one, right? So find one is a common property from a database, and so you pass in, right here I'm mocking this object in my testing suite, right? And then what should happen is in my model, everything that needs to read from the database reads from a database that is passed into the constructor. So I've kind of flipped this on its head, and what I've started doing, or what I was doing before I just switched completely to snapshot testing, was I would overwrite these class values, right? So let's go to my mock testing suite. What I would do is I'd create a class. It's not really going to be a class because all it's going like I'm only going to implement this once, and it's going to be a lesson without prerequisites, right? And so what I'm going to do is I'm going to overwrite the model that is the lesson. This is essentially the lesson model, and I'm going to overwrite the function that reads from the database, right? And so I'm overriding this so that now I have this new model that I can test other functionality on without having to spin up everything around it, right? I don't actually have to spin up a database. I can just call this commit file object, which is representative of a database in this program, and I would get the mock object that I basically returned here. All right, and I do that multiple times, and then when I actually go to the unit testing suite, what do? Well, I expect that the name of this is name. I expect that the dependencies is in empty array. I expect the message to be test message. I expect the type to be tech lesson, right? So what functionalities that actually test in my actual model? Well, this one's actually quite simple. The commit file is what reads from the database, and so the name, what it does is it reads that commit file object. So that commit file object isn't there, it reads something else. And so I've tested basically just this one line of code. I have no coverage over anything that's happening in the commit file function, but I have coverage over everything that happens in name. Basically, well, not everything. But I basically only test this one line. I don't test this this line down here. And so, let me show you what this looks like on the course level, because this is going to look a little bit bigger, right? So, what do I do on a course? Well, I overwrite the lessons, right? So I take the mocks that I developed in the tech lesson folder. I have these mocks that I basically said, okay, this extends model, and all I'm doing is overwriting the commit file. And I'm doing the same for the course level, but I'm taking the primitive objects that I mocked out in lessons, right? And so now this mock now depends on the lesson mock, and so there is like some sort of integration there between these two different services. It's not fully, like I'm not doing like an acceptance test where I'm spinning everything up and it's running on basically a data test. So yeah, so I have a 3 lessons course, and then I mock out the tech lesson IDs and then the tech lesson. So now let's actually go to the integration test, because this actually starts behaving like a tech, do I not get the mock? Oh no. Okay, this used to, well, it's a unit test work on it. Oh, these aren't good tests. Right, so this is where I actually use that 3 lessons model. I still call it a unit test, and it might be better off described as something else. I test the tech lesson IDs. Is that a valid test? Let me actually see. So it might be the case where here I actually I'm testing the thing I'm mocking out. So I made fun of people to do this, and it turns out my testing suite does exactly this. It's probably because at a certain point this function was implemented differently, and I wasn't mocking it out. And then I fixed the test in another PR, and all of a sudden, this test does not give me any coverage over my testing suite. It's a meaningless test. Because all it tests is my mock things.
Oh, I see.
The ordered IDs, on the other hand, actually does test something, right? So if I go to the definition of where this comes from, this actually does, it reads this object ordered tech lessons. Ordered tech lessons is a topologically sorted graph, which all that means is that things that are dependencies of something come after the things that they're dependent on. So that's what topological sorting is. And so when I'm testing for ordered IDs, I'm actually running this function. I'm getting coverage on this function, running this function. But it turns out that when I go to edges, I'm also testing edges and I'm getting coverage on this. But then edges is actually this tech lessons. Doesn't call the tech lessons that's in this file. Or maybe it does. No, it doesn't. Yeah, well, it does. So I'm missing a couple, sorry. Where was I? I was in the model, right? So this tech lessons then calls tech lessons IDs, and so IDs gets overwritten in my mocks, and so at this point it's going to actually go reference my mock when it does that. And so this is how I'm literally overriding certain values, because what this function does in the model is it reads files on my system, tests them, which is going back to how I'm using my file system locally as a database. So this is how I'm mocking out that database value, right? By literally saying tech lesson IDs now returns this mock object, right? So here I actually do get some coverage, right? When I test out, going all the way back to the top, I was validating ordered IDs. I was validating ordered tech lessons. I was validating edges, and I was validating tech lessons, and the rest of it is mocked out, right? So I have no coverage over this, or I have no coverage over this, but that's not what I was testing for coverage. And again, this is not how I've seen most people do it. How I've seen most people do it is they'll pass the tech lesson function in, or they'll pass in like a database that allows you to read tech lessons, and that's how they'll when you create the object, you get to mock it out. Whereas the way I create mocks is I overwrite the lower level implementation. So what ended up happening? Well, then I ended up basically creating an integration test where what it does is I don't mock or override any values, and I've created a content test folder. So this is basically my test data that I have locally. And this is how all of these files are saved. These are basically objects. These could be considered objects in the database, right? Where a file.txt is literally a file. And the commit.yaml, like they could be considered objects in the database, but I'm just doing all this locally. The prod one is a lot more detailed, right? Because this is what my production system is going to look like. This is the data that I want in my production system. But I don't want to be testing on my production system because there's so much more stuff. Anyway, so I end up writing integration tests over this content/test folder. And what ends up happening is I slowly start to realize that all of these end up just being snapshots of values on my course. And some of these do add, like, say a little bit more. Like here I'm saying that if, with my test content course, if I get the lesson that corresponds to the base lesson, the ID should be equal to this. It's a bit meaningless, but if I test, I know I actually do this, where I test, oh, here I test that, no, here, here I actually test the dependency IDs, right? So I want my first tech lesson, I want to test that the dependency ID of it is the base commit, right? So all that's saying is that this lesson depends on some other lesson, right? And the opposite of a dependency, I'm calling it enablement, so I also test that. Well, what ended up happening is every time I change functionality, I'd come in here anyway, and I'd start just being like, oh, okay, I changed functionality, my test is failing, let me change, I changed what an ID is, right? So instead of having YAML on it, let's say I dropped the YAML. And so I just manually update that. At that point, I'm realizing I'm not actually, like, when my tests are failing, I'm just updating them. And so what's the difference between that and snapshot testing? And I came to the conclusion that there's actually very little between how I was using my testing suite and what a snapshot would give me. And so I essentially implemented what this does is it queries a tech course for all of these values. And then what I do is I use Jest to validate that snapshot. And so you can see the output of that is literally this file here. Right, so this is what it expects to be validated against. Is this snapshot file. I can actually show this fit. Well, let me do it here. Problems, debug terminal. There. What do I call this? All right, well, I'll just run the entire testing suite. It's going to pass, so that's not very exciting. But what I'll do momentarily is I'll make it fail, and then we can actually see how it fails. My application's running somewhere else. No. Campaign test. All right, so all these are going to pass, and that's not very interesting. But let's say I actually want to change the data, right? And that way we can actually see that the test fails. What I'm going to do is I'm going to change the actual message in here. All right, so now this is going to fail. So basically what happened is all of my tests passed because my code, nothing's changed in my code base. Now what's going to fail is this, the snapshot's going to fail is because I have the message in the snapshot and I haven't updated snapshots yet. And the other point I'm going to make is that I also still don't actually look at the failed snapshots. What I do is I just update the snapshots, and then what I have is I look through the file in VS Code, and I can see where the lines changed. And be like, okay, this line I actually want changed, this line I didn't want changed. Right? So here it says the snapshot failed. Right? When I'm actually working on this, I don't just run the testing suite. This is what happens when I'm actually trying to push code. Oh, it failed again there. Right, so two of them, or no, one of them failed. So what's the point of like people like one of the problems is that people will update tests without realizing it, or they'll update tests and because they think that's the thing that they should do. And I've started doing that, which can be bad practice. But then when you kind of commit the code, you have to look through it, right? So here I had three changes in my code. I had a file change in my commit. What did I change here? Oh, that's useless. I don't want that anymore. And in my unit test, yeah, I don't need that anymore. Yeah. So after this, all of my tests are gonna pass because I'm updating my snapshots as my tests are running. And so I'm not relying on my testing suite to tell me when things change. I'm actually relying on the source control to tell me things change. So what's ultimately gonna happen is that I'm gonna be able to correlate this change in this file to a change in a snapshot. So what I can say is, okay, I did expect that this one small change ultimately was meant to affect this snapshot, and so I'm going to commit both. And this kind of goes back to a point I've mentioned a lot, is like being very iterative with your code and making small commitments so that you can actually make small changes and see how it changes your code base. Right? And we see right here that the snapshot was updated. I'm actually going to see in my acceptance test, this is the line that changed. Something else failed. It's a problem for another day. But yeah, so basically what I can look at is I can be like, okay, was I expecting this file change to create this change in my code, in my snapshot? Yeah, so what I'm going to do is I'm going to add both to my commit, and I'm going to commit both. Right, that makes sense. And that's what I do a lot of now. And for a solo project, I think it does provide a lot of the benefits that I want from testing, because I see when things change, and that's like the most important thing I really want in a solo project. In like a production system with other companies, I probably don't trust my coworkers as much to like be diligent about knowing how things change, so I wouldn't fundamentally rely on this in the same way that I do that here.
Gotcha. Yeah, that's a good philosophy for a solo project.
Yeah. All right. That was a lot of information. Do you guys have any questions?
It was definitely a lot. I can't say I have many questions because it does kind of vary based on, I guess, the project that you're working with. But I thought it was a really good, I guess, introduction and rundown or an implementation of how to test.
Yeah. And I wouldn't say my opinions are like very well reasoned about, in the sense that I've changed my testing opinions so frequently in the past that even if they sound like strong opinions, like I still don't know a lot. There's still like so much out there that I'm having trouble reasoning behind and figuring out what the best way to do it. Because on some level, like this whole like I'm changing one file and it's interacting with another. Like if I did this and I had integration tests or